Okay, so let's look at this polar question. This was the question from 2014. So 2 years ago, there was apolar. Last year was parametric. This year?
Hope not. Fingers crossed.
We don't know, so let's be ready for anything. That's somebody's motto, isn't it? Okay, so for one, how do we represent the area of this shaded region? Anybody? Okay, we're going to use an integral, maybe 2. Okay, so one thing we need to notice, guys, about this integral is that it is divided into 2 separate regions. This region is controlled by which function? R equals 3. And this region goes from what to what? Okay, it goes from pi over 2 to pi. So for this one, we can do 1/2, because that's the formula. Pi over 2 to pi 3 squared. Okay? That will get us this area from here to here. Does everybody see that? How do I get the area from, how do I get this area? So this area would be the integral from what to what? 0 to pi over 2. And it is this, it's not really a Lemaitre. I guess it is a Lemaitre. I don't know what the 2 theta, I'm not sure. But this would be 3 minus 2 sine 2 theta quantity squared. Okay? Yes? And then we would just do this on our calculator. Once again, we don't want to be a hero. We're just going to put it in our calculator, and it was 9.708. Yes? No. No. I've never seen it ask that. I guess I shouldn't say no so emphatically, but I've never seen it ask for volume. Okay, so for B, what are we going to have to use for B? If you are given a polar graph, a polar question, somewhere on there, you're probably either going to have to use x equals r cosine theta or y equals r sine theta. In this case, we have to use x equals r cosine theta. So if you get a polar, I would write that at the top of the page, knowing that somewhere in there you're probably going to have to use that. Okay? So knowing that x equals r cosine theta, then, oh, by the way, how much was this worth?
3.
This is worth 3 points. Where do you think the points come from? The limits and integrals. So 1 point for the limits and 1 point for the integral. So that's worth 3 points. How are we doing so far? Yes?
So, could you use for the second quadrant, this has a circle, the quarter circle?
Yeah, absolutely. With the radius of 3? Yes. So he's asking, could we, but if you look at it, this will actually give you the area of a circle. It's a quarter circle. So instead of doing it this way, you could have done 1/4 3 squared. 1 pi over 4, 3 squared. Would have given you the same answer. Okay? Good seeing that. Okay, so then we get x is equal to 3 minus 2 sine 2 theta cosine theta. And they want us to find dx, d theta, when theta is equal to pi over 6. Now, how would you do that? What's the best way of finding this? By hand? This is calculator active. So you would be in just your regular mode on your calculator. You would be on the home screen. Well, you could be in polar mode. It doesn't matter. But you would be on the home screen, and you would do d dx, d theta of this, and evaluate it at pi over 6 using your derivative function on your calculator. But you did have to write this down. You did have to write x is equal to this. Remembering, if you miss the parenthesis, it's wrong. All parentheses matter. So that gave us negative 2.366. Okay? Does everybody know how to do this on your calculator? Yes? Okay. All right, the next question wanted to know the distance, and it wanted to know the rate at which the distance is changing. Now, I'm telling you this, and I've said this yesterday, I've said it again. Well, I ask you this question. What is the most tested thing on the AP exam? Applications of derivatives. It is the most tested thing on the exam, because even though applications of derivatives is a calculus AB topic, in this calculus BC topic, in the last two questions, they threw in an applications of derivatives. It's the most tested thing on the exam. So if you only have time to study one thing, study applications of derivatives. So the first thing we had to do was write a formula for the distance. And we're looking at the distance only in quadrant 1. So what would be the distance, but how would I write an expression for the distance between the circle and the Lemachon? Yeah. So this is 3, because this is on top, minus the bottom. So my distance formula would be 3 minus parenthesis 3 minus 2 sine 2t theta. The 3's zero out, so the distance would be 2 sine 2 theta. And then on my calculator, I would find the derivative of this at, where are we looking? Pi equals 3? Or pi over 3? Okay? Which gave me negative 2. Also, another thing is that, remember, this was question number 2 on the free response. The last two questions, you will notice, you can get the answer without a calculator, and that's generally the case. Because you can, when they tell you to put your calculator away, you can continue working on these questions. You just have to do it without a calculator. So you'll notice, like, the last part of this is going to be something that you could do without a calculator. Okay? All right, so we got d equals negative 2. d theta was equal to negative 2. And the last one is a particle is moving along the curve. So that d theta dt is equal to 3. Find the value of dr dt. That's once again an applications of derivative problem, because what are they asking you to do? Take the derivative how? Implicitly. So you have to remember to use chain rule here. So for d, we get r is equal to 3 minus 2 sine 2 theta. The derivative of this with respect to t, the derivative of 3 is 0, so this would be negative 4. Is that right? Cosine 2 theta, and what's left? What else do I need? D theta dt. So this is negative 4 cosine of 2 times pi over 6. Now, if I had time and I still had my calculator, I would not be doing this by hand. I would be using the calculator, times 3. So that's negative 4 cosine of pi over 3 times 3. And apparently that will give you negative 6. I think. Okay? Also, know your unit circle. Don't miss the question because you can't find cosine of pi over 3. Okay? Any questions? Okay, are we all good? All righty.